Greetings, friends. In this video, we're going to continue our investigation of quantitative research methods and specifically our investigation into the bell curve and specifically standard deviations. Now, standard deviations are ways for us to understand what's called the shape of the distribution of a population group. And there's a tremendous amount of math that's involved in understanding how these particular calculations are derived and how they were even created in the first place, well beyond the scope of our interest or even our interests in this class. All we need to know, all we need to remember, is that a standard deviation is a way to describe how far away from the mean or a mean score or an average score a particular segment of a population group is. So the way that we talk about standard deviations is to talk about them as being 1, 2, or 3, or 4, or 5, or 6, although those other ones aren't shown in this diagram. How far that is from the mean. So one standard deviation from the mean is everybody who scored this far away from the mean. 13.6 or rounded to 14 is how many people scored this far from the mean, and add another 2% this far. So if everybody who took a test or was sampled would have their scores fit on this distribution, about 64% would be what's called one standard deviation from the mean. And then this group would be added 14 to it, and so on. So we do this in order to be able to see what the shape of the data is, and basically how far the distribution from the mean is. If all these scores are packed very tightly, then the standard deviation would be quite small, and you wouldn't have very much variance. That people would be rather homogeneous, that they all would score pretty much alike. If there's a large standard deviation relative to the mean score, that would be called a heterogeneous distribution, and there would be tremendous differences between the groups. Now, these are very helpful because it helps you as a researcher be able to describe individual students or groups of students' performances. So what we want to do is to take a look at this bell curve and standard deviations and to see how that helps us as researchers. I'm going to use a couple of examples here, and these are taken from Marzano's What Works in School, and you can see how powerful this kind of a interpretive tool can become. So let's say that there was a score on some kind of a standardized test, and the mean score was 70, and the standard deviation was 10. That would mean that, and also in this case, that 70 was also considered to be meet standard. We're just going to use that arbitrarily for the sake of this example. So if we went back to this slide, we would say that this mean score was 70, and one standard deviation was 10 points more than 70, so 80, 90, 100, 70 here, again, 60, 50, 40. Okay? So the way we would interpret this is that 70, half the people were above 70, half the people were below, half the students in this case met the standard, and half the students did not. Then along comes this program that we heard about, the ABC Enhancement Program, and it's been shown in a number of studies to increase test scores by one standard deviation. That will mean that now instead of the average student or this class average or group average being 80 or being 70, it's now going to be 80. And that will mean, and we'll demonstrate this in a second, that now 84% of the people will meet or exceed the standard, and only 16% will fail to meet that. So let's see how that works. So here's this score, this group that took this test, and here's their scores. And we said 70 was the mean, and half the students scored above, half the students scored below. And remember how we divided those percentages up? First standard deviation, because see how much larger this part of the curve is, that means more students will have scores in this part of the bell curve. 34% above, 34% below. And then 2 standard deviations away, well, another standard deviation will capture 14% of the population. The third standard deviation and beyond, another 2%. Same thing with below. The question is, what would happen if you increase achievement by 1 standard deviation? Well, if you did that, here's what the new distribution would look like. And instead of the mean being 70, which is what this bell curve represented, now you have a new mean score of 80. And here's the new bell curve that captures the score, the new score of all the students who took the assessment. Now look what happens. You took this group right here and you move them now here to where they are now receive passing grades. And look what happens now when you add up the number of students who passed. You add all these together, 34, 34, 14, and 2. You add all those together and you get 84%. So now here's passing. 84% of the students now have passed, and only 16% have not met standards. So you can see that a 1 standard deviation increase in an achievement makes a significant difference in the percentage of people who pass or who improve. Now, what Marzano has done is he's created a statistic that helps to explain this phenomenon, and it's called effect size. And effect size is based on standard deviation, and an effect size of 1 represents an increase of 1 standard deviation in test score achievement or in improvement. So we would say that moving from 70 to 80 is a 1 standard deviation improvement, or a effect size of 1. And what Marzano has done is studied his achievement, student achievement, and the kind of what kind of improvements, what kind of changes in instruction or school climate can account for various kinds of improvements in student achievement, and capture that in a number called effect size. So what we want to do is to see what kind of a difference that makes. So we're going to take this one right here. It talks about the effect of discipline across grade levels. And so we want to study is what happens when a school improves the way that it in classroom management practices, or what we would normally call discipline. So he would say that it increases student achievement by almost 1 standard deviation. So how do we compute what to expect if that really were to be the case? So let's say that we're using this new discipline system that's going to bring discipline to our unruly students. We would expect, if the research held true, that there would be an improvement in student achievement from 50 to some other number. So how are we to figure that number out? Well, here's the student achievement on a particular assessment. Right now, the standard deviation is 15. So students at 1 standard deviation above the mean are getting scores of 65. 2 standard deviations are getting scores of 80, and so on. Same thing would hold true for below the mean. What should the new average be on the assessment if the program is successfully implemented? Well, you take the effect size, multiply it times the standard deviation, and that will show you how much of an improvement there would be. Add it to the old mean. So whereas on the old, or the prevailing system, the average score of the sample was 50, we would expect with this new system for the new average score to be 63. Significant improvement. And all throughout Marzano, he has all these charts. Here's another one. The importance of feedback, giving consistent and immediate feedback to students as they're trying to learn new concepts, has a huge effect size. That's 1.3 standard deviation. So you'd expect a huge improvement. So we will do the same thing. Here's a 1.3 standard deviation. The test scores was average was 72. Here's the standard deviation. What would the new average be under this new instructional strategy? Well, we expect to improve from an average of 72 to average of 82.8. So Marzano, in his books, What Works in Classrooms, What Works in Schools, you'll find no shortage of these kind of charts. And so it's helpful for us as researchers to get a handle on what effect size means. And here's a chart where he actually does the math for us. But using that very simple formula of taking the effect size times the standard deviation plus the old mean score, it gives us a chance to see how much improvement we can expect if we implemented these instructional strategies. Importance of feedback, different types of learning experience. You can see that if you provide drama as a way for students to learn what the effect size difference and what that can mean in test scores. Well, that gives you a basic idea of how to use descriptive statistics, in this case standard deviation especially, to be able to conduct research and be able to understand it as well.